Today, I'll talk about relative dating techniques. Dating techniques fall into two major categories. Relative dating, in which time given is relative to other strata or materials. All you can say is that something is older than or younger than something else. Hence, it's relative. Versus absolute dating, in which you obtain a year or a range of years, giving a date in numbers. These two techniques are often combined. The relative dating techniques that I'll talk about today include stratigraphy, seriation, bone chemistry analysis, geochronology, and index fossil. Stratigraphy relies on Steno's law, or the law of superposition. This states that in undisturbed deposits, deeper strata are older. Now, I just used a lot of vocabulary. Strata refers to layers. This is one of those Latin words, and it follows a Latin conjugation. So, singular, we would say stratum, meaning a layer. Strata, layers. And stratigraphy refers to layering. These layers may be layers of rock, as you see at the Grand Canyon, or layers of dirt, as you see at the Rift Valley of Eastern Africa, or even as you see at an archaeological site in central South Carolina. Let's begin with the layers of rock that can be seen at the Grand Canyon. The Grand Canyon began forming 60 million years ago when colliding tectonic plates pushed the Colorado Plateau higher in elevation. Subsequently, over the next 54 million years, the Colorado River carved down through the plateau, exposing ancient layers of rocks. As you can see from this sketch next to the photograph, the most recent or youngest rock layers are at the top, the Kaibab limestone, 250 million years old. And as you go down or lower, you see the older rock layers, all the way down to the Supai sandstone, 285 million years old. Turning now to the East African rift system, what you see is a canyon that is forming as two continental plates pull apart. To the north, you see the Red Sea, where the plates have already separated. And then to the south, you see two branches, an eastern branch and a western branch, where that part of Africa to the right or to the east is pulling apart from the rest of Africa. These pictures illustrate the steps that occur in a situation like this. First, you get warping of the lithosphere and the beginning of the formation of the divergent plate boundary. Then you see the formation of a rift valley, and the East African Rift Valley is at this stage. Next would come the formation of a linear or narrow sea. The Red Sea is at this stage, and eventually you will see the formation of ocean with the well-developed mid-oceanic ridge. Here's an aerial photograph of a part of the East African Rift Valley, where it's very narrow in this section. At the top, again, it illustrates the two continental crust boundaries, plates pulling apart. And on the bottom, you see a wider section of the Rift Valley. Some of the earliest human fossils have been found in the Rift Valley of Eastern Africa. Now I'll turn to an archaeological site in central South Carolina. Here I excavated down through the layers of dirt through what had been an earthen mound. And I'll tell you my interpretation of the different strata or layers that I see. I'll start at the bottom, which is the oldest or original. What you see here, the midden AB horizon, it was the ground surface at about AD 1200. I can tell that it used to be a surface because of the types of soils that are there, an A horizon and a B horizon. You can see that it had been at the time cross-cut by a wooden post, which since has rotted, and then the hole has filled in with dirt. So people were living and working and throwing trash down on this ground surface, leaving what we archaeologists call a midden. That's trash mixed with the dirt. Then they decided to build an earthen mound. Their first mound stage, they took dirt from elsewhere on the site because it had artifacts in it. I know that it came from on the site, and it wasn't very tall, maybe a little over a foot high. But then they went off-site and deliberately collected 3 different colors of dirt that are sterile. They have no artifacts in them. So they collected yellow dirt, gray dirt, and black dirt, and they built the mound higher. In fact, they built it higher than is shown in this photograph. But eventually the Indians left this site, and in the 1700s, Euro-Americans moved in and began farming. And in doing so, they reduced the height of the mound, and what is left today is a plow zone. This is the depth to which the plow cut down and is totally mixed what's left of the mound. The second relative dating technique that I'd like to talk about is seriation. And seriation relies on the principle that as human behavior changes through time, so too do its material products. So it's a technique to put artifacts in order by sequence. What's an artifact? Well, it's an object that has been made by humans, or even an object that has been used or altered by humans. There are 2 types of seriation. One is called stylistic seriation, where you take one kind of artifact and put it in order based on similarities in style. So similarities that change gradually. This putting in order could reflect either a time change, that through time the style changes, or could even reflect spatial distance. That is, here where it first originated was popular, but then it spread outward and people didn't quite get the style right as you went out. One example of this would be to look at jeans through time, or, as illustrated here, Coca-Cola bottles. So you take one kind of artifact, in this case, a type of bottle, or you could do this with jeans. You could do this with hairstyles. I bet you look at historic photos and kind of guess, oh, that's the 1960s. That's the 1950s, based on people's hairstyles. A second type of seriation is called frequency seriation, where instead of ordering just one kind of artifact, you take all those kinds of artifacts. You take an assemblage and order the assemblages, the collections, by the relative frequencies of artifact styles within each assemblage. So we assume that among all the different kinds of pants you could choose, for example, when do jeans, for example, rise and fall in popularity? Actually, they've been very popular for a long time, so they would not necessarily, in a frequency seriation, be a good indication of time. So we assume that different styles rise and fall at different rates. So in this case, instead of looking just at jeans, you would look at all long pants. Or instead of looking at just Coca-Cola bottles, you'd look at all soft drink bottles. So here's an example of stylistic seriation, where you order one kind of artifact by similarities in style. What you see here are, by decade, different styles of automobiles. Or here, the sequence of early Paleo-Indian points in the southeastern United States. When archaeologists make posters like this, they always show these in stratigraphic order. That is, the oldest points are at the bottom and the most recent ones are at the top. And you can see that these go from about 13,250 years ago up until about 11,700 years ago. You can see that some of these have names written below them. And each of these with a name is what an archaeologist, the type of artifact that an archaeologist calls a type. A type is one kind of artifact with a set of shared characteristics. Types are limited in space, time, and cultural association. Thus, a type, if you find an artifact that has a type name, can tell you the time period of the stratum or the layer in which you found it. I'll give you an example here where we used seriation. We were excavating over in central South Carolina. This is a 2 by 2 meter unit. And at the base of the plow zone, the mixed up zone, we found this sharp line between midden, the black dirt, and not midden. Now, you see a sharp line like this only if you have a ditch or if you have a wall. So it indicated the location of a ditch or a wall. So here it is again on the right. Originally, a layer of midden covered all the ground. And what we discovered once we cut into it was that people had dug a wall trench, that is a narrow ditch, into the midden. So here's the narrow ditch that they dug. And then they put a wall or a palisade inside that ditch. So this is one way to build a wall. Instead of digging an individual hole for each post, a faster way is to dig a narrow ditch, put in your upright posts, and then put in a locking horizontal log, and then backfill. This is what they did here. Subsequently, on the right-hand side, they continued, that was the inside of the wall, and on the locking log side was outside the wall. They continued to throw their trash down, and so the midden built up higher on the right-hand side, as you can see in the top photograph, than it did on the left-hand side. So to date construction of the wall trench, I could seriate pottery, that is broken bits of trash pottery, from the midden above it and from below it. And indeed, down below it, we found this pile of broken pottery. And by looking at the style of the pottery, we could tell that the pottery dated to the 1500s. Therefore, the wall also dates to within the 1500s. The pottery looked like this. It has a very distinctive decoration up near the rim of the pot. So these are sherds, broken pottery vessels. Here's an example of a frequency seriation in which you order assemblages by relative frequencies of artifact styles. And we assume that a rise and fall in popularity of styles occurs through time. So in this case, the assemblage is all the headstone decorations seen at a particular northeastern United States cemetery that has graves dating between the early 1700s to the early 1800s. And you can see that they have looked at 3 of the different decorations that people had on the tombstones. And back in the early 1700s, if you had a decoration on your tombstone, it was a death's head. But beginning in the mid-1700s, the cherub starts to rise in popularity. And as it's rising in popularity, indicated by the width of the bar, which equals the percentage of headstones, the death's head is falling in popularity. And then later in time, the urn and willow become a more popular carving to put on your tombstone, and a cherub fades out. So by the early 1800s, you don't find any death's head or cherubs, only urn and willows. Now this is an extremely clever illustration. For one thing, the whole illustration is in the shape of a headstone. But also it shows you along the edge here how the actual style of death's head changed through time. So it started out looking very much like a skull. But then it got more stylized. Here's my favorite one. It looks like Donald Duck. And till by the end, it was extremely stylized. So by the 1790, it would have looked like this one down here. So you can see that even when you're checking assemblages, also within each assemblage, the style of each item in the assemblage may be changing. Okay, the third type of relative dating technique I want to talk about is bone chemistry. And this measures the amounts of elements or minerals in bone that has been buried. Now, to do so, we need to understand the taphonomic processes that affect bone. So taphonomy refers to the processes that affect bone after the death of the animal. Not all animals or humans who die end up with bones that archaeologists can examine, and certainly even fewer end up being fossilized. Taphonomic studies tell us that bones lose organic components, such as nitrogen, and gain inorganic or mineral components, such as fluorine or uranium. And the rate of the organic loss and the rate of mineral absorption will be unique for each location, because each location has a different kind of dirt, different environmental factors, different climate, and so forth. So the bone chemistry relative dating technique is good only within any one site. It can tell you whether one bone at a site is older than or younger than another bone at the same site. One type of bone chemistry analysis is fluorine absorption analysis. It's based on the idea that bones at any one location will absorb minerals, in this case fluorine, at the same rate. Thus, older bones will have more fluorine and younger bones will have less at that site. Now, this relative dating technique can work on bones, but it cannot work on fossils, that is, bones that have turned to rock. Another relative dating technique is geochronology, in which you determine the age of something by the association with geological formations or activities. So if you can date the geological activities, then by using stratigraphy, you can give a relative date for your artifacts or for your stratum, your layer. For example, volcanoes are famous for spewing out ash plumes. And so a whole cloud of ash comes out and settles down and covers the ground. For example, on the right, you see a pit where I can count at least 6 layers of ash from different volcanic eruptions. So if you know when the volcano erupted for any one of these layers, you can date things below it or above it, relatively speaking. So strata below an ash layer are older than the volcanic eruption. There are many volcanoes in the Rift Valley where the 2 continental plates are pulling apart, which is lucky for us because there were at times large layers of ash, and the most famous of these is at Laetoli in Tanzania, where 2 of the earliest humans to walk upright walked toward, or they actually walked away from the volcano as it was erupting. They were walking in the wet ash as it was falling. And at one point, the 2 of them turned around and looked back at the volcano. And then they turned back and walked on. Another relative dating technique is called index fossil dating, also sometimes called faunal succession. So index fossils are the remains of long dead animals or plants that lived during a known period of time in the past. So especially when you have an assemblage of these remains, not just one kind of animal or one kind of plant, but a mixture of several kinds of animals, several kinds of plants, you can know what period of time other remains found with them belong to. Here's an illustration. What this shows you is that some fossils, like these over here, are not good time markers because these types of organisms lived for a long period of time. However, some only lived for a relatively brief period of time, and where those overlap, then you could say that's the age, if you have some other way of dating it, that's the age at which these animals lived. So here we have an example of an unknown fossil. How old was it? Well, it's found associated with these three that are not good time markers, but it's also associated with these two, and the point at which these two overlap is here. So therefore, this fossil must date to this time period. This technique can be used to date early human fossils in areas like South Africa, where no volcanoes have left behind ash layers, but where we do have lots of other fossil animals mixed in next to or near the human bones. So to summarize the relative dating techniques, I talked about stratigraphy, seriation, two types of seriation, stylistic seriation or frequency seriation, bone chemistry analysis, geochronology, and the index fossil concept. Remember, relative dating refers to a time that is given that is only relative to other strata, layers, or materials. You can't give an actual year. All you can say is that it is older than or younger than something else.